Welcome to another episode of AI 10X brought to you by 10 Leaves.
Glad to be here for this one.
So imagine walking up to your front door and it just opens. You don't fish for your keys, you don't, punch in a code, you don't even perform some specific secret knock.
Right, the door just knows.
Exactly. The door simply recognizes its owner and the mechanism unlocks. Now imagine your entire digital life, your banking, your confidential work files, healthcare portals working exactly the same way.
It's a wild shift to think about.
It really is. And we are looking at a deep dive into the source text, AI, and digital identity, authentication in an autonomous world. And the mission for today is to explore this fundamental shift in how you live your life online. Because the systems we currently rely on to prove you are undergoing a radical AI-driven transformation.
Yeah, and the transformation the source outlines, it's really born out of structural failure. I mean, the architecture we have relied on for decades to secure digital environments, it's entirely buckling under the pressure of an autonomous internet.
It's just not working anymore.
Not at all. We are moving toward a state where secure and intelligent authentication isn't just a nice-to-have feature, right? It is the load-bearing pillar of the modern digital economy. And the immediate implication of that is the complete obsolescence of the password.
I mean, I really don't think anyone listening is going to mourn the death of the password.
No, definitely not.
We all know the friction of getting locked out, the credential stuffing attacks, the endless data breaches you hear about in the news. But what strikes me in this text isn't just that passwords are annoying or insecure.
Right, it goes deeper than that.
Yeah, it's the underlying logic of why they fail so spectacularly in a modern context. It comes down to this concept they talk about, the static credential.
Right, so a static credential is just a piece of information you possess,
Yeah.
or a physical object you hold, like a password, a PIN code, a hardware token, even just a physical key to your house.
Something you have or know.
Exactly.
Mm-hmm.
And the inherent unfixable flaw in any static credential is that it can be separated from the user. It's a piece of data that exists independently of your actual human identity.
Which is the scary part.
Right, because if a system relies on a password, it is entirely blind to the actual identity of the person typing it in. The system only authenticates the credential itself.
It's like the secret knock analogy, right?
Right.
Like if a clubhouse requires a highly complex secret knock to get in, the door doesn't actually care who is knocking.
It just listens for the rhythm.
Exactly. Anyone hiding in the bushes can watch you do it, memorize the rhythm, walk up to the door 5 minutes later, perform the knock, and gain full access. The architecture verifies the action, not the actor.
That's a great way to put it.
But that leads me to a fundamental question about the premise of this text. By replacing that secret knock with artificial intelligence, are we just making logging in faster, or is AI fundamentally changing what it means to have an identity online?
Oh, it fundamentally redefines the architecture of identity.
Yeah.
I mean, in the static model, your digital identity is essentially a locked box. You prove you have the key once at a specific point in time.
Like at the login screen.
Right, the login screen. And then the system assumes you are the rightful owner for the remainder of that session. But AI shifts us from that point-in-time verification to a continuous dynamic state of identity.
So it's always checking.
Yes. It allows us to move away from authenticating a disconnected credential and move toward authenticating the human being in real time, continuously.
Okay, so we are moving from what you know to how you exist. And that brings us to the mechanics of it all. Because if we are ditching the secret knock entirely, how exactly does an AI system authenticate you?
Well, the source goes deep into decoding this, pointing to a combination of biometrics and behavior.
And I actually want to pause on the biometrics part for a second, because I think there is a huge misconception here. When people hear facial recognition, they imagine a database sitting on a bank server with millions of JPEG selfies of their customers.
Oh yeah, that is a really common but highly inaccurate visualization of how modern biometric authentication works at the enterprise level.
So what's actually happening?
Well, the AI doesn't store a photograph of your face or an audio recording of your voice. When you register your face, the AI analyzes the unique geometry. So the distance between your eyes, the depth of your eye sockets, the contour of your cheekbones.
Just measuring the physical structure.
Exactly. And then it converts that physical geometry into a complex mathematical vector. It's a cryptographic hash.
Meaning it's a string of numbers that represents my face, but you can't reverse engineer those numbers to actually draw my face.
Correct. You can't turn the math back into a picture. The system only compares the mathematical output of the live scan against the stored mathematical baseline.
Wow, okay.
That is just the physical, static biometric layer. Where the autonomous world truly differentiates itself is in the secondary layer the text emphasizes, which is behavioral biometrics.
Yeah, this is the part that genuinely gave me pause. Because the source states that these AI systems recognize users through the unique way they interact with their devices.
It's pretty incredible.
Wait, so it's not just scanning my face, but the AI actually knows the specific rhythm of how I type, or the arc of my thumb when I swipe, and even the angle at which I hold my phone.
Down to the millisecond and the millimeter. I mean, you have a highly unique subconscious way of interacting with the physical world. It's driven by your specific biomechanics and your muscle memory.
So the phone is literally feeling how I hold it.
Yes, the gyroscope in your phone knows the exact customary angle you hold it when you're, say, lying in bed versus sitting at your desk.
Hmm.
Capacitive touch sensors register the microscopic variations in pressure you apply to the glass.
That's so specific.
It gets more specific. The system measures what they call dwell time.
Dwell time.
Yeah, how long your finger lingers on a specific key before releasing it. And flight time, which is the exact duration it takes your finger to travel from, like the A key to the T key.
But wait, human behavior isn't perfectly static, right? What if I just drank 3 cups of coffee and I'm jittery?
That's a classic example.
Or what if I sprained my wrist and I'm typing with my other hand? Or I'm walking down the street instead of sitting on my couch? If my identity is tied to a specific behavioral rhythm, won't any deviation lock me out of my own life?
So that is the critical engineering challenge here. And it's exactly why the text emphasizes real-time risk analysis rather than simple pattern matching.
Okay, how does that differ?
The AI doesn't look for a 100% perfect match to a static behavioral template. Because, as you pointed out, humans are inconsistent. We change based on context. Instead, it builds a dynamic confidence score.
A confidence score.
Yeah. So if your typing speed suddenly changes because you are walking, the AI doesn't panic because it simultaneously pulls data from the accelerometer, confirming the rhythmic bounce of footsteps. It contextualizes the anomaly.
So it understands why my behavior changed.
Yes, exactly. But let's look at a malicious anomaly just to compare. Let's say you are initiating a massive wire transfer from your bank.
Okay, high stakes.
Right. The physical device is yours. The facial scan matches your vector. But the AI detects that the typing cadence is completely foreign.
Oh, interesting.
The pressure on the screen is erratic. The gyroscope shows the phone flat on a table instead of in a hand. And the flight time between keystrokes matches a known bot pattern rather than your human muscle memory.
So even though the face and the device check out, the behavioral biometrics scream that something is wrong.
Exactly. The real-time risk analysis engine flags the deviation immediately. This is the shift to continuous authentication.
It never stops watching.
Right. In the password era, once the hacker got past the login screen, they had free reign. But in an AI-driven behavioral system, the authentication is continuous.
So what does the system do when it spots that bot pattern?
The system might respond to that anomaly by introducing cascading friction. So perhaps halting the transfer and demanding a live voice prompt, or just freezing the session entirely until secondary verification is cleared.
Okay, I want to introduce a metaphor here to make sure this lands for everyone, because the shift from point in time to continuous authentication is massive.
Feel for it.
The password model is like a bouncer at a club who checks your ID at the front door. Once you are inside, you can do whatever you want, right? The bouncer assumes you were supposed to be there.
Because you passed the initial check.
Exactly. But this new AI model is like a bouncer who checks your ID at the door, but then follows you around the club all night, constantly watching your body language, observing how you hold your drink, analyzing your posture.
That's a bit creepy but accurate.
Right. And if you suddenly start moving like a completely different person, the bouncer intervenes.
That captures the mechanism perfectly. It creates this hyper-secure profile that is incredibly resilient to spoofing. I mean, a malicious actor cannot simply buy your password on the dark web anymore.
They'd have to buy your habit.
They would have to literally become you, replicating your exact subconscious muscle memory and biomechanical rhythms in real time. It provides frictionless convenience for the legitimate user who is just operating their device normally while presenting a near impossible barrier for an attacker.
I understand the security appeal, I really do. But, hearing you describe the bouncer watching my Every micro movement brings up an inescapable issue.
The privacy side of things.
Yeah, the level of tracking required to make this autonomous authentication work is staggering. I mean, if my device is pulling thousands of data points a second regarding my physical movements, my location, the pressure of my fingertips, the geometry of my face,
That's a lot of data.
we are no longer talking about storing a scrambled password on a server. We're
Oh,
talking
yeah.
about digitizing my physical existence. What happens to all of this deeply personal data?
Which brings us to the core tension in the source material. The text explicitly states that building these smarter systems is only half the battle.
Right, the tech is just the start.
It's exactly. The major challenges accompanying these technologies are privacy, data ownership, and ethical use. This transitions us from a pure engineering problem to a really profound societal and architectural challenge.
Because if that central database, the one holding the behavioral and biometric models of millions of users, if that gets compromised, I can't just hit a reset button.
No, you definitely can't.
If a password database is breached, I spend an annoying hour changing my passwords. But if a corporation leaks the mathematical model of my face and my subconscious physical rhythms, I can't get a new face. I can't easily rewrite my muscle memory.
The vulnerability profile changes completely. The stakes for secure data storage are astronomically higher now, and this is why the architecture of these systems is currently the subject of intense debate.
So who is responsible for keeping this safe?
Well, the organizations deploying these continuous authentication models must transition from being mere service providers to being the ultimate stewards of highly intimate human data. The entire framework collapses without a foundation of absolute user trust.
Let me challenge the architecture then, if you don't mind.
Redo.
If an AI system knows my behavioral patterns and voice better than I do, who actually owns that digital version of me? Like, why does a central server need this data at all?
That is the million-dollar question.
Right. If the goal is just to verify that I'm holding my phone, why send my flight time keystroke data or my facial vector across the internet to a bank's server? That feels like an unnecessary honeypot for hackers.
You've identified the exact pivot point in the industry, and it's a concept necessary to resolve this whole privacy dilemma, which is edge computing or localized processing.
Edge computing. Okay.
Yeah, the ethical and secure consensus forming right now is that this intimate data should never actually leave your physical device.
Okay, unpack how that actually works in practice. How does the bank know it's me if they never see the data?
So the AI model that learns your behavior and stores your biometric hashes, it lives entirely on your device, usually within a dedicated physically isolated piece of hardware called a secure enclave.
Okay, so it's locked down on my phone.
Right. When you go to make that wire transfer, the banking app requests authentication. The secure enclave on your phone locally analyzes your face and your current behavioral inputs.
All happening right in my hand.
Yes. It compares them against the local baseline. If it determines a match, the enclave generates a cryptographic token. It's essentially a complex, unforgeable digital signature that simply says, yes, this is the authorized user.
And it sends that token to the bank.
Exactly. It sends only that token to the bank's server over the internet.
So the bank only receives a thumbs up or a thumbs down. They never see the geometry of my face. They never see how hard I press the screen.
Precisely. The raw behavioral and biometric data never touches the cloud. It is processed at the edge of the network, meaning on the local device itself. This is what mitigates the risk of a massive central honeypot being breached.
Well, that definitely mitigates the central breach risk, but it still requires a massive leap of faith, doesn't it?
Wow.
It requires us to trust that the hardware manufacturers, the companies building these secure enclaves, are playing by the rules. What if there is a zero-day exploit in the hardware? What if a government mandates a backdoor into that enclave?
Those are very real, very valid concerns.
As this technology becomes more seamless and invisible to the user, our reliance on the integrity of the creators becomes hyper-visible.
It does. And this is the crux of the data ownership debate highlighted in the source. Because the ethical mandate is that the user must retain ultimate sovereignty over their biometric templates.
Meaning I have the final say over my data.
Yes. If you decide to leave an ecosystem, you must be able to verifiably destroy that local enclave data. Trust cannot just be a marketing buzzword here. It has to be mathematically and legally guaranteed.
Because if users feel surveilled rather than secured, the whole autonomous world project fails.
It falls apart entirely.
We want the convenience of the door unlocking automatically. We despise the friction of the secret knock. but we absolutely demand assurance that the door isn't secretly compiling a dossier on how much we weigh, what mood we are in, and who we are talking to while we walk through it.
Navigating that exact balance is what will define the next decade of digital infrastructure. We have to design systems that are completely opaque and impenetrable to attackers, yet entirely transparent to the user regarding how their identity data is leveraged.
It's a dual challenge.
Yeah, the intelligence of the AI is only half the equation. The structural integrity and privacy guarantees are the other half.
So bringing this all back to you, the listener, and what this deep dive means for your day-to-day life. The core thesis from our source material is profound. In the autonomous world we are rapidly entering, your identity will be powered by continuous intelligence, but its survival depends entirely on trust.
Beautifully stated.
The friction of the password is fading. It is being replaced by a digital environment that simply recognizes you by the very nature of how you exist within it. The geometry of your face, the acoustic resonance of your voice, the subconscious rhythms of your fingertips.
It is a remarkable leap forward in mitigating fraud and providing seamless access. But as we've explored, shedding the static credential demands an equally massive leap forward in our technological architecture and our definitions of digital sovereignty.
And before we wrap up, there is one final provocative horizon the source text mentions that I really want to leave you with, and that's AI in metaverse
Oh
economies.
yeah, this takes it to another level.
We've spent this time talking about banking and emails on a smartphone. But imagine a very near future where our physical and digital lives blur entirely in immersive spatial computing environments. You aren't just logging into an app, you are conducting business, signing contracts, interacting in a fully virtual space.
Right, you're embodied in the digital world.
In that environment, proving your identity isn't just about accessing a file, it is about proving your very existence in the digital realm.
And the continuous behavioral monitoring we discussed would be absolute in those environments. I mean, your gaze tracking, your micro expressions, all continuously analyzed by the underlying architecture to verify you are who your avatar claims to be.
Exactly. So here is the scenario to ponder. What happens when the AI is the sole arbiter of reality and it gets it wrong?
That's a chilling thought.
Imagine you are in an immersive metaverse economy, about to close a major contract. But maybe you're exhausted. Maybe you are recovering from a physical injury and your natural rhythms, your gait, your posture have fundamentally changed for the day.
The system would notice.
The continuous risk analysis engine detects the anomaly. The bouncer taps you on the shoulder. The system wrongly flags your real-time behavioral patterns as an imposter, and suddenly the digital world decides you aren't you.
You're locked out of your own reality.
In a world where passwords are gone and the machine relies entirely on its algorithmic analysis of your subconscious behavior, how will you prove to a machine that you are actually you? It is a fascinating, complex, and slightly terrifying thought to carry with you as these technologies roll out. This episode of AI 10X was brought to you by 10 Leaves.